And then we'll be taking up the third homework sheet on graphs of polynomial functions. So the reason why we have a third homework sheet for this lesson is because I would argue this is the big lesson or big idea of the whole unit, is your ability to graph a polynomial function from factored form. And if I were to give you the graph, can you generate the equation of the polynomial function? So really, that's the big idea of this unit when we're talking about polynomial functions. So I give you f of x here, and I ask you for the y-intercept. I ask you when is f of x less than 0. I ask you when is f of x greater than or equal to 0. So to find the y-intercept, quite simply find f of 0. And that was actually very easy because 0 times anything is 0, so f of 0 is 0. When is f of x less than 0? Now there are a few ways to do this. You could use an interval table, okay? And the next question as well, you can use an interval table to find out when f of x is greater than or equal to 0, but it's much easier just to graph the function. If you're able to graph the function, all you have to do is now look at the graph, and then you can determine when f of x is less than 0. Because when it's less than 0 is when the graph is below the x-axis, right? If it's below the x-axis, it's less than 0, f of x, that is. So that's how I got these two intervals. When is f of x greater than or equal to 0? So once again, we're going to use the graph instead of the interval table. We're going to use the graph and look at when it is above the x-axis. Now be careful, I'm going to look at when it's above the x-axis and when it's on the x-axis, because I'm asked when is f of x greater than or equal to 0. So when is it above the x-axis and when is it on the x-axis? Okay. For the second question, they ask us to determine an equation. They give us the zeros and the respective orders, and it passes through a point, negative 6, 18 in this case. So I write down the factors with the correct exponents given the orders. Now, please don't assume that the number that you factored out is 1, okay? That's like saying if you have a quadratic from grade 10 and you quite simply just assume that the number was 1. You can't assume it to be 1. You have to solve for it by using a point that's on the parabola. Well, in this case, you're using a point on the quintic. Anyway, sub it in and then solve for A. The next question is a very nice question. Most students find this one challenging. So I have 4 criteria that must be fulfilled by this graph of the polynomial function. So it has to be degree 8, has to be greater than 0 over these two intervals, has these 4 x-intercepts, and the y-intercept is negative 4. So the very first thing I did was plot the y-intercept and the x-intercepts, because that I really can't change that. And then I have to make sure that it's greater than 0. It's positive on these intervals. So then I basically imagined humps over here. But you might be tempted to just connect the dots and draw your polynomial function. But because it's degree of 8, you can't cross it linearly, because that would result in a degree of 4. So I did a degree of 3 here. So this 0 has an order of 3, order of 3, order of 1, order of 1. So 3 plus 3 plus 1 plus 1 will give you a degree of 8. All right, so that was a little trick you got to be careful with. If the degree was 4, then sure, you could do linear. But since it's degree 8, you have to be a little fancier. You could have done, I'm just thinking, is there another way you can do 5? You could do 1, 5, 1, 1. So another, you know what, I'll show you. You could have done some negative 4, that you can't change, negative 1, negative 2, 1, 2. So these things can't be changed. So you could have done a point of inflection here, a point of inflection here. So this polynomial, well, that's not very pretty, but you know what, you're going to live with that. This polynomial is also degree 8 because order of 1, order of 5. This could be 3, 5, 7. We're going to say 5 though. So order 1, order 5, order 1, order 1. And if you sum that up, that will give you a degree of 8. Okay, so different ways to do it. You could do order 1, order 1, order 5, order 1 as well. So yeah, as long as it fulfills all the criteria, you will get full marks. All right, intervals where f of x is less than 0, where it's greater than 0, ask for end behavior and the symmetry. So I gave you the graph. So when is it less than 0? It's never. So you can use the word never, or you could be a little fancy and say null. So null basically means never. X is for no values of x will f of x be less than 0. When is it greater than 0? I gave you the 3 intervals. It'll be here, or here, or here. So remember to use a union symbol, and behavior is pretty straightforward. Now symmetry, a lot of students make a careless mistake here. All they write is just line symmetry, but you have to be way more specific about that. You have to say line symmetry about y-axis, or line symmetry about the x equals 0 line, or something like that. You can't just say line symmetry, because line symmetry can occur anywhere. So for example, this function here is line symmetry, okay? And this function here is line symmetry. But this is line symmetry about the y-axis. This is line symmetry about some other vertical line. So you have to be very specific when you state line symmetry and point symmetry. Okay,